Hello, it is your teacher Adam Billman again, and I'm here to go ahead and teach you how to solve equations. This right here is going to be a nice simple video called Solving Equations 101, because I know that some of you guys have trouble with solving equations and are a bit embarrassed to actually ask for help. So I thought I'd make this video, which will be a nice primer for those of you who've forgotten how to do this. Now this is a basic algebra skill. I usually taught this all the way back in middle school, once again taught again in Algebra 1, but the main thing is that this is a major requirement in order to be able to pass any algebra class, including Algebra 2. So for our first problem, and this is the simple prototypical problem, we have a simple linear equation, 3x minus 4 is equal to 5. This sort of problem is actually quite simple to solve, and a lot of you guys have probably already figured out how to solve this. Even if you don't really understand how solving works or why it works, you probably already know what solving is. And your immediate thought might be, okay, well, what I need to do here is I need to go ahead and get x by itself, so I always get rid of addition and subtraction first, so I'm going to go ahead and do the opposite by adding 4 to both sides, leaving me with 3x equals 9. Going ahead and continuing that, writing this out, 3x equals 9. You then say, well, x is still not by itself, so then all I need to do is divide both sides by 3, because that is the number that we have here, in order to cancel it out, leaving you with x equals 3. Since 9 equals 3, you end up with x equals 3. And a lot of you guys might have figured this out and are thinking to yourself, okay, this is trivial, I don't need to watch this video. But one of the big questions, one of the big things I notice with a lot of students is that they can solve this problem very easily. But if I make one small change, make it negative 4 plus 3x equals 5, their immediate thought is going to be that they don't know how to solve this problem. They'll stare at this and they'll be convinced this problem is somehow unsolvable. And if they do try something, they'll try something like, they'll try to subtract the 3 because that's the thing that has the plus on it. Or they'll try to divide the negative 4 because it's over here. They don't understand what's really happening. And that's sort of the problem, is that a lot of people who are solving these things have learned through rote that you're supposed to just get rid of the subtraction and then do the division. And when the problem looks like this, that's easy, it's trivial. But the moment that you change this order, it's actually the exact same. And that's the thing, it's the exact same, but most of my students do not know this. They're convinced that these two are somehow different, and the steps are different, but actually the steps are the same. You would still add 4 to both sides at the start. And the reason why you'd add 4 to both sides is because even though this right here is a negative 4, a lot of people don't understand that this negative 4 is still subtracting the x, even though it's not behind the x. The mere fact that it's negative is what matters. The fact that it's negative and not multiplying the x is what makes it subtraction. But yet they're convinced that that's not the same. They'll be convinced that somehow this does not work. But once you do this first step, guess what? Everything is exactly the same. You just divide both sides by 3 and you end up with your final answer of x equals 3. So the question really comes down to understanding PEMDAS. Now, most of you guys have memorized the acronym PEMDAS, but a lot of you don't understand it. But the reality is PEMDAS, this tells you how to simplify a problem. So if I was trying to simplify a problem, then I would go ahead and follow PEMDAS from top to bottom in order to simplify. That's just simply put the easiest way to handle it. Right, so I want to simplify. This is what I'm going to do. But when you're trying to solve, this is not our goal. Our goal is actually to go ahead and get rid of everything that's surrounding it. Our goal ultimately is to get rid of stuff from the outside in. And so we're not trying to simplify, we're trying to solve. And when we're trying to solve, we actually go in reverse. And this is going to be something that's going to come up over and over again. So why are we doing it this way? Why do we get rid of that minus 4 first? And the reason is because what it's doing to this x is it's subtracting. And since we're trying to solve the equation, we're going to follow PEMDAS in reverse. And getting rid of subtraction is our first goal. Get rid of that subtraction. Let's look at the second problem. Now, PEMDAS tells us that we need to go ahead and get rid of the subtraction first, or the addition first. Remember, parentheses, those always come first, which means that when you're solving, they must come last. So we're not going to touch this set of parentheses here. We're instead going to get rid of this 5, because this 5 is adding and would therefore go last if we were simplifying, and so will therefore go first when we're actually solving. So I'm going to go ahead and get rid of 5. Remember, our goal is to do the opposite, and the opposite of addition is subtraction. This process of doing the opposite is what is called performing the inverse operation. And this will give us 4 times the quantity of x minus 3 equals negative 8. Now at this point, our thought might be, okay, we might want to get rid of that 3 now, except we can actually deal with the multiplication first. You will be told that you should go through the process of distributing the number in there first in order to go ahead and simplify the side. That is totally an option. In fact, feel free to do it. But the reality is this isn't actually necessary. If you understand the simple fact of PEMDAS, but in reverse, that has, say, the SADMAP method, then you recognize that you don't actually have to distribute this 4 at the very beginning. You can instead simply divide the 4 during this step. Now that's not always the best move. Sometimes it's better to distribute, sometimes it's better to divide. And really what it comes down to is what all the numbers look like. Frequently, my rule is I do the division rather than the distribution if I can evenly divide into this number. And I will distribute if I can't. This way, at the very least, I can deal with fractions only at the end instead of in the middle of the problem. But realistically speaking, there's no reason why I have to actually do it in any particular order, as long as I remember to go in reverse order. So, dividing 4 from both sides instead of distributing will give me x minus 3 equals negative 2. And if I then add 3 to both sides, this will then leave me with my final answer, which is x equals 1. Of course, if you don't trust this, you could go ahead and try the problem again. This time, however, following that pattern exactly as you originally were told. That is to say, you could go ahead and do the distribution if you don't believe me. You could distribute the 4 into the x and into the 3 as your first step, which is what most teachers would tell you, at which point you'd end up with 4x minus 12 plus 5 equals negative 3. Combining like terms, which would be, in this case, these two, the negative 12 and the 5. Combining those like terms, we end up with 4x minus negative 12 plus 5 would be negative 7. And then adding 7 to both sides, because at this point it's just a simple, it's just the simple pattern that we're all used to. So just add 7. So you end up with 4x equals 4, which, when dividing by 4, will leave you with x equals 1. Same answer both times. But notice how many more steps it took to solve this. Whereas this one only required 1, 2, 3 steps. This required 4 total. 1, 2, 3, and 4. So keep in mind that sometimes using the SADMAP rule will actually simplify the problem, making it easier. Now, Here is one where a lot of students are going to have problems. Now, we're currently learning exponentials at this point, and a lot of people will then start to freak out over this. And the reality is that as long as you understand the basics of the SADMAP method, this really isn't anything new, right? SADMAP, that is to say, PEMDAS backwards. We have to just deal with the subtraction and the addition and the division and so on. Of course, sometimes you want to simplify first, so you can sometimes think of the S as being subtraction and simplifying, in which case, in this case, I'd probably simplify this side first. The 17 plus 6 isn't a very difficult problem right there. And then just multiplying that by 2 and you're done. 17 plus 6 happens to give you a total of 23, times 2 gives you a total of 46. The other side remaining the same. And now, this is where a lot of people then start having problems. Okay, well, how do I solve this? Because they'll see this x, but they don't understand how to solve it. But once again, think of it in reverse order, just SADMAP. And once you get that, you realize that we have several operations. My x up here is all up here in this exponent, which means I can't touch it yet, because it's all up here in this 3. So I can't really touch this. You can think of this as being like a sort of parentheses that aren't really there. You can think of that as parentheses that aren't there. So that means it goes last. This 3 to the power of this quantity, x minus 1, this right here is an exponent. So clearly it can't go, it can't go yet. 5 is multiplying the 3, which comes before that. And finally, this 1 is adding onto all of this junk, which goes here. So once again, following SADMAP, we get rid of the addition. The addition, subtracting that 1 from both sides, leaves us with 5 times 3 to the power of x minus 1 equals 45. Now, once again, following back through, the multiplication comes next. And the multiplication in this case we have to get rid of is this 5. Opposite multiplication is division. So dividing both sides by 5, we end up with the quantity 3 to the power of x minus 1 equals 9. And now we're at the exponent. We're now here. And just we have to get rid of this. Now, remember, this right here is not going to be, say, 2 to the, is not x to the second power. This is 3 to the x minus 1 power. This is an exponential. And since the opposite of an exponential is a logarithm, we're going to go ahead and take the log of both sides. The log in this case being the log base 3 of both sides. I didn't leave myself enough room over here, so I'm going to write the log base 3 right here. Or actually, better than that, I'll just erase this and move it over so that you can actually see what I was doing as opposed to trying to guess what I was doing. Once again, when you're only dealing with a single number or something simple like this, the parentheses are not necessary. But I prefer to leave the parentheses on because it makes it very clear what the argument is. Now, this all cancels out, so that leaves us with x minus 1 equals the log base 3 of 9. If we pulled up our calculator, we'd quickly see that this is 2. And adding 1 to both sides, since we're now inside the parentheses, we can finally deal with this negative. The opposite of subtraction is addition, so x equals 3. And there's our final answer. So one last problem. Once again, the main thing to remember is that it's always about asking yourself how to solve things. You can follow this exact order. The reality of math is if you understand the problem, it doesn't really matter. This SADMAP is a crutch. It's not really required in order to solve a problem. So what we could do instead is follow any order we want. You want to distribute first? You can distribute first. You want to divide both sides by 7? First, go for it. As long as the rule you're following is followed correctly, you're fine. No problem is going to occur here. So, going ahead and following it this way, divide both sides by 7. We end up with 3x minus 1 equals 56 divided by 7 is a grand total of 8. Adding 1 to both sides gives me 9. And dividing both sides by 3 gives me x equals 3. So remember that the basics of solving equations is an absolutely necessary thing in order to do well in an algebra class. If you can do this, then honestly this is not a difficult class for you. But if you can't, then always feel free to ask for help or to get some practice, because this is a very basic skill and everyone really should have it. So I wish you guys a wonderful day, and I hope this finds you well.